All right, so as we take a look here at 57, we've been given radical p squared minus 5p plus 81 equals p plus 4. So we know that we need to solve for p, and right now we have p on both sides of the equation, don't we? On the right-hand side, we're free and clear, but on the left, it's under a radical. So let's go ahead, and to get rid of that radical, let's square the left side. But of course, whatever we do to the left-hand side, we also have to do to the right-hand side. So on the left here, that squaring is just going to eliminate our radical, and so we're left with p squared minus 5p plus 81 equals now p plus 4, that quantity squared. And so we know that when we have a binomial squared, it means that we have to take that binomial, write it out twice, and now FOIL. So what we end up with here is now p squared plus 8p plus 16. And if you FOIL that out, you'll see how that works out. So it looks like we have a quadratic going on, doesn't it? So let's go ahead and try to get everything to one side and set this equation equal to 0. So we'll start by subtracting p squared for both sides. But look what happens here. Just like with 56, our p squareds end up canceling. So we really don't have a quadratic here. What we end up with is just negative 5p plus 81 equals 8p plus 16, a basic linear equation here. So in this case, let's try to get p on one side and everything else on the other. And to do that, I'll go ahead and add 5p to both sides here. And that'll leave us with 81 equals now 13p plus 16. Still solving for p, we'll subtract 16 from both sides. And that'll leave us with 65 equals 13p. And solving for p, lastly, we'll divide by 13 on both sides. And so p equals 5. And if you take this value, plug it in for p, you'll see that you do get a true statement. And so we know that our answer, p equals 5, is correct.